In this video, we want to look at the quotient rule of differentiation. For convenience, the way to represent the quotient rule is that dy dx is equal to differentiate u, keep v constant, minus keep u constant, differentiate v, all over v squared. Now, what are the implications of this? If, for example, we are given to differentiate cos x over 1 plus sine x, and we're asked to differentiate this, we can use quotient rule to do this. Now, what we're going to do is that dy dx will be equal to, this is u, or let's say, first of all, let u be equal to cos x. Let v be equal to 1 plus sine x, so that dy dx will be equal to, if we differentiate u, we will get negative sine x, keeping v constant, 1 plus sine x, minus keep u constant, cos x, differentiate v cos x, all over 1 plus sine x all squared. The next thing we can do is to expand this. And if we expand here, we can have negative sine x, negative, that's this times 1, negative sine x, this times this, sine square x, then negative, this times this, cos square x. Let's bring these two people closer. If we bring them closer, we can say that negative sine x minus, being outside, sine square x plus cos square x. This factoring the negative sign out will make sure that when we multiply this, we'll get back this. When we multiply this, we'll get back this. All over 1 plus sine x all squared. The next thing we can do is apply the identity. There is a basic identity that says that sine square x plus cos square x equals 1. So the minus sign outside, we write it. This is 1. We put it down. All over 1 plus sine x all squared. We can also rearrange this. There's negative sign here. There's negative sign here. It can be equal to negative, being outside, 1 plus sine x all over 1 plus sine x squared. You can see this look like this. So it will take 1 from here. What we have left on top is negative 1 over sine x is still remaining here, sine x. So this is the answer. Let us look at another example. This one says differentiate x plus 2 over 3x plus 1. Remember, the one on top is u, the one down is v. So we can say let u be equal to x plus 2, so that if we differentiate u, we are going to get 1. Let v be equal to 3x plus 1, so that if we differentiate v, we are going to get 3. So we can now apply the rule that says differentiate u, keep v constant, minus keep u constant, differentiate v all over v squared, which is dy dx y prime. So here, if we plug it in, we will have du, if you differentiation of u, will have 1 times v being constant, 3x plus 1, minus u being constant, x plus 2, v being differentiated, 3, all over v squared, 3x plus 1 all squared. Now the thing is, open up the brackets, multiply by 1, you still have 3x plus 1 minus, use this, you get 3x then minus 6. Since the minus belongs to all of them, this times this is 3x, this times this is 6, so multiply all of them with the minus sign, it gives you the minus, over 3x plus 1 all squared. The next thing we can do is to see that here is minus 3x, here is plus 3x, so they can go. We have this and this, which will give us minus 5 all over 3x plus 1 all squared. That's the answer. The next question says differentiate exponential x over x squared. So you can pause the video and solve this particular one. Alright, let u be equal to exponential x, and so if we differentiate u, we'll still have exponential x. Let v be x squared. If we differentiate v, we'll have 2x. So that the formula we have differentiate u, keep v constant, minus keep u constant, differentiate v, divided by v squared. That is dy dx. So if we plug it in, we'll have ex equal to, if we keep v, x squared, let's use bracket to separate them, minus u ex v 2x all over v squared. The next thing we can do is multiply out. This and this gives us x squared ex minus 2x ex over x squared. Now this is the same thing as x4, or let me write it here, s4, 2 times 2, x4. We can factor x out here so that we can have x into x, which is x squared, then ex, then minus 2x ex all over x4. This x4 can take out one of this x, can take out one. What is left is x3. So seeing here ex is here, ex is also here, we can also factor out ex again. Let's rewrite what is remaining. Ex minus 2ex over x3. We can factor out ex and say ex into x minus 2 all over e3.